The next problem that we'll be doing is chapter 16, number 12. This problem states the mass of a string is 5.0 times 10 to the negative 3 kilograms, and it is stretched so that the tension in it is 180 newtons. A transverse wave traveling on a string has a frequency of 260 hertz and a wavelength of 0.60 meters. What is the length of the string? So basically what we're trying to find in this problem is L. You're not going to be able to fully understand what the problem is asking and how to attack the problem efficiently unless you write down the things that the problem has given you. The problem has given us, for the string, the mass and the tension. For the mass is 5.0 times 10 to the negative 3 kilograms. For tension, they gave us 180 newtons. They also gave us information about the transverse wave. For the transverse wave, they gave us the frequency, which is 260 hertz, and they gave us the wavelength, which is 0.60 meters. They're all in the right standard unit. And what the problem is asking us to find is basically the length of the string, which will be expressed in meters. In order to attack this problem, we will first use the equation given in the textbook. I believe it's equation 16.4. I would have to double check. But that problem equation is velocity equals the square root of force divided by mass times length. What we're trying to find is length. We are given everything in this equation except for the velocity. But we know from the equation 16.2 that velocity is equal to frequency times wavelength, two components which we were given. So in order to find out the length, we are going to have to substitute the velocity for frequency times wavelength, which would then give us the equation, as you can see right here, frequency times wavelength equals the square root of force divided by mass times length. So now all we're going to do is be solving for L. We're trying to find the length of the string. So in order to do that, we're going to take the square root, we're going to square everything to get rid of the square root. So we'll have like F, the frequency squared times wavelength squared equals F divided by M times L. So you're going to just manipulate that equation to get L by itself. When you do that, you're going to have this equation. L equals frequency squared, wavelength squared, times the mass divided by the force. So everything we've been given here is what we've been given in the problem. So basically all now you have to do is plug and chug. So what you will have is L equals 260 hertz squared times 0.60 meters squared times 5 times 10 to the negative 3 kilograms, all divided by 180 newtons, which is the force, to give you the length of the string, which is 0.68 meters. And that's all you have to do to find the length of the string. Thank you.